because if we look at the level of intensity, if we were to draw it on a graph with the x-axis being the edge of this stage and the y-axis going this way, if we were to draw a graph of the intensity of the workout, what we'd see is that the needle would peg, go all the way across the room, out the door and out the front door of the hotel. But play activity, even those that are fairly boisterous and really get you huffing and puffing and stuff like that, they're probably, in terms of measuring intensity relative to that, are not going to go beyond this first row of tables. So it does have some effect on recovery, but I think it is important to incorporate playful physical activity. And if you find in your record keeping that the amount of playful physical activity that you want to incorporate is not allowing you to recover by the 7th day, or let's say you're working out every 5th day, it's not working, you're not progressing, but you don't want to give up the amount of play you're doing, fine, push your workout to the 7th day. If you start showing progress again, then hold it there for a while. And then if all of a sudden you have a workout where it doesn't progress, skip a week. Then come back at every 7th day, 2 or 3 weeks, skip a week. Or you can go to every 10th day. Or you can just mix it up. Or every 3rd workout, you can flip a coin. If it's heads, you work out. If it's tails, you don't. Doesn't matter, but allow for that recovery. And allow for it in a way where your life and your play and what you want to do is in the driver's seat and not the workout. Because in the end, that will get you the best results. Yes, sir.
I have one question. I've actually read the book, The Red Queen by Matt Ridley,
Yes.
and it's an awesome book. It's very informational and answers a lot of questions that I didn't even know that I had. But my question now is that there are these new systems for working out, nutrition, and health and things that are based on evolution. And through the history of evolution, our life expectancy was extremely short compared to what we're expecting to live now. So how can we base these systems on life longevity while for thousands of years we weren't living that long?
Okay. First is when you look at hunter-gatherer life expectancy, when you look at the anthropological studies about that, you got to realize that that's actuarial, okay, over an entire lifespan. And the vast, vast majority of that is accounted for a skewing of the median downward by infant mortality, okay? And this is one of my favorite pet peeves as an emergency physician, is it always just drives me freaking crazy when some granola head wants a nurse midwife to deliver their baby in their living room. And that shit pisses me off because when that baby comes out blue with a cord wrapped around its neck, they're dropping it in my lap on an ambulance, okay? If you have any historical graveyards in the town where you live, go visit it. Because fully 1/3 of the graves there are infant graves, okay? The vast majority of prehistoric humankind's mortality that made their life expectancy 30 years instead of 72 years has to do with the infant mortality associated with it, or simply becoming saber-toothed tiger shit at some point in your life, okay? This is the beautiful thing about technology and capitalism, is we can make mistakes and not die, okay? In emergency medicine, I have a very famous saying, and I like to say it a lot: stupidity is not a crime, but it is punishable by death. Nature is a hanging judge, and that's where our hunter-gatherer friends bit the dust. It didn't really have anything to do with anabolic-catabolic balance or long-term health benefits, because there were older survivors, and the fossil evidence of those older survivors based on ligamentous attachments and bony assessment and bone mineral density they were extraordinarily robust, okay? The Hadza tribe that lives in Central Africa is one of the few pure hunter-gatherer tribes that still lives as they originally did, and they don't even recognize a child as human until it has survived 3 lunar cycles, just to psychologically protect themselves from the high infant mortality rate, which also does 2 things, which sort of skews Mark Sisson and my argument about why evolutionary nutrition is such a boon, is that also you have a selection bias. Is if you're not good genetic material, you're not going to make it beyond 3 moons. That's the way it is. So the deck is kind of loaded in their favor just from a genetic predisposition, because you know, as far as someone like me, compared to your average hunter-gatherer that did survive, you know, probably to quote Full Metal Jacket, the best part of me ran down the crack of my mama's ass and wound up as a brown stain on the mattress. But so yeah, that has a point, but it doesn't really specifically apply when you actually parse the numbers out. Any others before we go to med school? How am I doing on time?
You got about 40 minutes, maybe a little bit less.
All right, let me fly. This is med school biochemistry in a nutshell, and I'm going to give it to you and you're going to understand it. This big square is a cell of your body, okay? Could be a muscle cell, any cell that you want to call it, okay? And what I've drawn up here is the metabolism in your body. This part of the cell is liquid. It's about 70% water. It's sort of like slime, ectoplasmic ghoul, if you will, that is the liquid interior of the cell, and it's called cytosol. Inside the cell is the little powerhouse of the cell called the mitochondria, okay? And metabolism shuttles through there. Your body takes glucose and through an insulin receptor passes glucose into the interior of the cell. Inside the cell are proteins or enzymes that alter the chemical structure of glucose. And in the process of altering its chemical structure, generate energy in the form of phosphates that can be used to drive the machinery of the cell. So it's sort of like generating biodiesel, if you will, okay? So you go through these processes of about 20 steps, and at the very end of it, you end up with a waste product called pyruvate. And when animals first were crawling around the slime in the very, very beginning of our evolutionary past, that was the extent of our metabolism. But somewhere along the way, little protobacteria and viruses got inside the cell and developed a symbiotic relationship with the cell. And basically they ate our waste products and used it for energy. And at that period of evolution, oxygen was starting to become present in our atmosphere. And these little protobacteria learned how to use oxygen to extract energy from our waste product. So what originally started as a parasite living in our cells became an organelle. And they use pyruvate and they cycle it through something called the Krebs cycle, and that ended up producing not 4 ATP, but 32 ATP. Well, they stopped being parasites and bacteria and actually became organelles inside of our cell, which became part of our energy architecture, okay? So, when we're making energy, the part that occurs out in the liquid part of the cell is anaerobic metabolism. And the part that occurs inside the mitochondria, driven by oxygen, is called aerobic metabolism, okay? Now, the weird thing is that even though this produces much less ATP, in terms of cycling this, in terms of turning the churn, this really hauls ass. And this is not so fast. So you can turn the anaerobic cycle really, really quickly. And you can make pyruvate faster than your mitochondria can use it. And when that happens, the pyruvate gets acted on by an enzyme called lactate dehydrogenase, and you end up making lactic acid, which is something y'all are all familiar with, okay? But in terms of an aerobic workout, to answer your question, the answer is that when you do truly hard work, you are going to cycle this anaerobic process as fast as it can possibly go. And the only way that you can maximally stimulate the aerobic metabolic cycle is by delivering as much substrate as it can handle. So to the extent that you can really ramp this up, you are conditioning this as much as possible. My workouts take about 8 minutes once a week. My resting heart rate's about 48 to 50. Okay? It's because of this. Here's the other thing, is you go down to Patrick's place or you have Drew Bay put you through a workout. At the end of the workout, you're going to be laying on the carpet. And what you're going to be doing on that carpet is taking all this pyruvate that you made quicker than the mitochondria could use it and got turned into lactic acid. While you're laying on the carpet, your body takes that lactic acid, brings it back through the central vein of your liver, and in the liver cells there, that lactic acid gets converted back to pyruvate, sent in the bloodstream, sent to your mitochondria, and shuttled through the aerobic cycle. So while you're laying on the carpet recovering, then you get in your car, you go back to your job, you sit at your laptop. For the next hour and a half, you're getting a superior aerobic workout compared to walking on a treadmill for the same period of time. So you are upregulating that aerobic metabolic cycle during that recovery period because you actually did it hard enough to matter. Okay? So that answers the aerobics question. But you kind of get the idea of how energy moves through this whole process. Now, let's talk about Mark Sisson's diet and how it fits into this whole thing. Now, if we are in a fully anabolic state, if anabolic is out of balance relative to catabolic, then we have plenty of energy coming in here, cycling through the process, and in the process of taking all this and converting it to ATP, a byproduct gets stacked up called citrate. Well, citrate acts as a feedback mechanism to a linchpin enzyme in the whole process called phosphofructokinase. It's not important that you remember that. Just know that it's there because this is like the thermostat at the back of the room. And this is like the cold air coming out of the vents. Okay? So when you're in an energy replete environment, getting lots and lots of carbohydrate, lots and lots of glucose, this comes up here and blocks phosphofructokinase. Well, what happens then? You can't go down. Well, all these enzymes that are doing this work are bidirectional. So what ends up happening is you go backwards because your body doesn't want all this glucose stacking up inside the cell because that glucose binds to proteins. It's called glycation byproducts. And it mucks up the metabolic machinery just like pouring pancake syrup on the keyboard of your computer would. Your body doesn't want it, so it wants to protect itself. So it goes backwards up here, and then there's an enzyme called glycogen synthase. And you take those glucose molecules, and you hook them all together like Tinker Toys into this big thing, and you store them in your liver, and you store them in your muscle. But you store about 70 grams of glycogen in your liver. And you can store about 200 grams of glycogen in your muscle. And they're in those two different locations for two completely different reasons. The reason it's in your liver is to maintain a stable blood glucose. If y'all are getting hungry because you hadn't had your snack, then what's going to happen is you're going to release a little bit of glycogen from your liver to maintain a stable blood glucose. And that's important because our major evolutionary DNA-driven process that brought us here today was a big brain. That was the evolutionary gamble that worked because some hominid ancestor actually found the ocean and ate lots of omega-3 fatty acids and got a big brain. Okay? But a big brain requires a constant influx of energy. So if it dips a little bit, you tap your liver glycogen, maintain a stable blood glucose so your brain keeps working. Okay? Now, the glycogen that's in your muscle is there for a completely different reason. It's there for emergency on-site usage. It's like the coal car on the train. It's right there to be used on the spot by the muscle in question. Now, take your DNA, go back in the evolutionary basis, the most likely time that an animal is ever going to get attacked is when it's at the watering hole or when it's feeding. Its guard is down, it's concentrating on an anabolic process, and on a dime, it has to turn its metabolism from anabolic to catabolic.